In this section, we're going to talk about transformations of functions. And for this one, I'm mostly just going to look at how to apply transformations to functions. Some of the practice problems and the examples in the text will show you how to actually, apply these to different functions. And so the different transformations that we're going to see, there's a few different types. There's shifts, there's reflections, there's stretching or shrinking, and then there's the even versus odd. Okay, so we're going to start with the shifting. So there's two types of shifting. There's vertical and horizontal shifting. For the vertical shifting, if c is greater than 0, then I can take my function f of x and apply c to it by either adding or subtracting. If we add, then it's going to shift my graph up c units. So if this is my basic curve here, then if this is my value c, meaning that's my c units, then there would be my shift up of c units. If I'm applying it this way, where I'm subtracting c from my function, then I'm going to shift my entire graph down c units. Okay. For the horizontal shifting, these are the shifts that apply to my x values. So if c again is greater than 0, and I add c to the x's and then apply the function, this is going to shift my graph left c units. So from here it would come over here. And again, it's the same graph, just shifted over. Okay? And if c is subtracted from x and then f is applied, then it's going to shift the graph right c units. So here it would do something like that. Okay. For the reflections, there are two types of reflections. And the best way I think of reflections is if I'm looking at a portion of the graph and I held a mirror up to it, what would the other portion look like? And so it's going to depend on where I put that mirror. And for our two reflections that we're going to talk about, we're either thinking of putting the mirror on the x-axis or on the y-axis. Okay? Now, in general, there are other types of reflections, but for this class and for what you're going to need for calculus, these are the two types that we're going to talk about. Okay? So if I'm looking at a negative f of x, this means that if I put a mirror on the x-axis, so I'm going to reflect about x, I'm going to get the same picture. Okay? And so if I put that negative in front, all it's doing is making all of my function values negative. Okay? In this case, if I put the negative on the x instead of on the f, then it's going to reflect about the y-axis. Because now I'm going to take all of my x values and make them negative. So if I put the mirror here, it's going to reflect this way. Okay. The next types of transformations we're going to talk about are our vertical and horizontal stretching or shrinking. Okay? And so these, again, we're going to take this real number c and we're going to apply it to the function value by multiplying. So instead of adding or subtracting, I'm now thinking of multiplying or dividing. So I'm going to take some number and multiply by the function value. This is going to give me a vertical stretch. And it depends on whether c is bigger than 1 or less than 1 to whether it's actually increasing the size of the stretch or decreasing the size or shrinking. So if c is greater than 1, then my stretch is actually going to increase. So in this case, if I'm looking at my curve here and my c is greater than 1, then what happens is it's going to increase quicker for each y value. And the best way to look at this is if I take a y value here, an x value here, and I find the corresponding y value, the value for the stretch should be c units times that. Okay? So if this is a 1, this is going to be c. Okay? The same thing is true of the shrink. So if I'm looking at my curve and I'm looking at c where c is less than 1, Now remember, c is greater than 0 here, so I'm thinking things like a half or a fourth, some fraction less than 1. Then what happens is, again, if I look at my x, I'm going to take that value, wherever that is, so let's call it 1, I'm going to take 1/6 of that. So this would be 1 over c. And so it's going to shrink vertically what I'm looking at. So the y values actually go down, whereas over here the y values actually increase for that same x. The horizontal stretch does the same thing except in the x direction. So again here the c is being applied to the f value. Here we're going to apply the c to the x value. And so here when I shrink it by 1 over c, what that means is, again, if I'm looking at a y value in here, so for any y value I pick, the x value is going to become, so for example, if x is, or c is 2, I'm going to get half of that. Okay, so it's going to shrink it horizontally. And so what happens is my graph is going to look about half the size of the original. Okay, so it shrinks it. In the case of c being less than 1, what's going to happen there is, again, if I pick the y value and I go to that corresponding x, wherever that x is, I'm going to stretch it by 1 over c. So again, if c is a half, then I'm actually stretching by a factor of 2. And so what happens here is my graph is going to increase or double. And I didn't leave enough room over here to write that out, but you get the idea. It's going to stretch it horizontally. Okay. And then for even versus odd, this basically just tells us the type of function we're looking at. And again, it goes back to those reflections we talked about. So if a function is such that if I put a negative in for the x, I get the exact same value for the positive x, then we call that an even function. And so here's an example of an even function. If I look over here at x and over here at negative x, the function values are going to be the same. Okay? And it doesn't matter where I pick that, it's the same on either side. So it's kind of a mirror on the y-axis. If I'm looking at something where I put a negative in for the x and the answer comes out to be the same as the negative of the positive x, then it's an odd function. Okay? And so here again, if I pick an x over here and I get this positive value, when I come over here to the negative side, that same value should be negative. Okay, so if this is y, this is going to be negative y. Okay, and so here we can think of these in terms of symmetry. So if I'm saying it's even, this is going to be symmetric about the y-axis. And if I say it's odd, then it's going to be symmetric about the origin. Okay. So there are all the different transformations that you're going to be asked to use. And again, one of the things you're going to be asked to do is, given a graph or a function, be able to apply these transformations. One of the things to keep in mind as you do this is, if I have multiple transformations that I'm applying, I always want to start with my horizontal shifts, or anything being applied to the x value. Then I want to go to the vertical things, or the things being applied to the y values. Okay? The best way to think of how to apply them is to use your order of operations. So if I'm plugging in, what operations am I going to do to that value first, and then proceed in that order. In some cases, you will find that you might have 1 or 2 different things you can do. So for example, if I'm reflecting, meaning putting a negative outside of my function, and also multiplying it by a value, it's not really going to matter what order I do these, but I should always do those probably after I've done a horizontal shift. Okay? So keep that in mind when you go through the example problems from the text and the practice problems that are assigned.